Hello everyone. This is Deepak Kulkarni, working as assistant professor in the Department of Electronics and Communication Engineering. My topic of presentation is one of the application of machine learning algorithm, rather prediction of house rent by using machine learning algorithms. So let me give some prerequisite to understand the topic of the delivery. If we want to if we want to build any model using machine learning algorithms, right? What are the general steps that we need to follow? So let me go one by one. So the first step is the data pre-processing. So in data pre-processing, there are different steps. So first one is the exploratory data analysis. So what is that exploratory data analysis? It is nothing but it is an approach in which the data set, whatever we are using, we are summarizing. We need to summarize the main characteristics of the data set. And how we are doing this? It is with the visual methods, graphical methods. So there are two types of analysis. First one is the univariate, second one is the multivariate analysis. So what is univariate analysis? It is an analysis in which the data, whatever we are analyzing, it is consisting of only one variable. And what are the best examples? It is nothing but the box plot and the histograms, the graphical methods that are used. Second one is the multivariate analysis, in which the data, whatever we are using, it consists of more than one variable. And how the multivariate analysis is performed? It is by using either scatter plot or bar charts. What are bar charts? If the data is the category, if the variable is categorical variable, then the bar charts are used. All right. Now, data, whatever we are processing, it could be either a continuous or a numerical variable, or it could be a categorical variable. Now, what is numerical variable? For example, if we are interested in finding out what is the bike rent by calculating the distance given its longitude and latitudes. So the final answer is in terms of numbers. So that is numerical value. Other way, if you just take an example of whether a person is diabetic or non-diabetic. So there are only two categories of the variable, diabetic and non-diabetic. So this is called as categorical data or categorical variable. So categorical variables are best represented using bar charts. All right. Yes. So next part is the missing value analysis. Now, what is missing value and how the missing values arise? When we convert the data from unstructured format to a structured format, at that time, while converting, that is from a raw data set into a usable form, there are some values that are left blank. So those values are called as missing values. All right. Now, what is the danger that is caused by missing values? We call it as treating of missing values, right? The very important thing is machine learning algorithms, whatever we are using, they do not support data with missing values. So whatever is the missing value that is present, it is treated as NaN, not a number, right? And we will end up with a model which gives not so good answers. Rather, they don't, machine learning algorithms do not support that data. So we need to eliminate those missing values, right? And one thing we need to remember very clearly that there is not a unique, there is no one unique method of dealing with missing values, right? But if there are missing values, then we deal with missing values by different means. Okay, so if you just look at this, handling missing values, if there is missing value, then it depends upon which type of problem we are dealing with. So whether it's time series data or it is a general problem. All right. So right now we are, the problem of our interest, what I have considered is a continuous variable, right? So in that, if there are missing values, then it is imputed by means of either mean. What do we mean by impute? Impute is nothing but wherever there are missing values, just fill up those missing values either by mean, median, or mode, or by some other means. So we don't want to keep it blank, right? So there are two possibilities. One is you entirely eliminate that row which consists of missing values, or you substitute the values which is either mean, medium, or mode will not come into picture when it is continuous variable. Okay, so either mean or median, right? Or there are some other imputation techniques. Okay, so this is about the handling of missing values. And next comes the outlier analysis. Now, what are outliers? Outliers are the data points. Okay, so what are those data points which are far away from the median? Okay, and another point to remember is there are techniques like scatter plots, box plots, which give us how to detect the outliers. Okay, outlier, for example, if there are 10 people who are standing in a queue who have the height of around 4.5 foots, and if there are some people, or there are two people out of 10, there are 6 or 7 people who have the height of, average height of 4.5 to 4.8 feet. Next, there are 3 people who have the height of 6.5. So they are deviating from the median, right? So those are the outliers. Okay, so that's what is mentioned here. There is something called as interquartile range. So it is the difference of Q3 and Q1. So what is Q3 and what is Q1? It is clearly mentioned. It is 25th percentile and 75th percentile. Okay, and how to treat that outlier? It is again same as the missing values. Okay, you use it either by mean, median, or mode, or any other methods. And finally, we extract the features and we take the samples. And what is that sampling? Whatever data is available, 80% of that data is classified as training data and 20% is classified as testing data. And finally comes model selection and model evaluation. Right. So this is regarding the presentation. So let me take you to the code which I've written using Python so that it can be clearly understood. Yes. So if you just look at this, we have the, just a moment. you just look at the notebook, Jupyter notebook, what I am using. So this is the home page of Jupyter notebook that I am using. There are many more platforms. There is Writer, wherein you can write your code. I have used Jupyter Notebook. Even you can use Google Colab for that matter. So this is the Jupyter Notebook. First point is we need to import all the necessary libraries. So it is import OS, pandas, everything. Matplotlib is used for plotting the graphs, even Seabot the library, and all these are the libraries that are required for different models. Let's begin with the data. So this is the pd dot read underscore csv. So it is used to load the data set into the Jupyter notebook. Finally, next is the training dot shape. Okay, so with that, what will happen? Training dot shape, it gives us how many rows and how many columns are present. So there are 10,692 rows and 13 columns present in the data set. Okay, so which are those variables? We'll look into that. So first one is the fire insurance. So fire insurance cannot be a value which is 0. So if there are any values with 0, then we are going to drop that. So training dot drop. So this line of code, so it is going to drop the variables which have value of fire insurance equal to 0. Okay. So similarly, there is another variable city. Okay. So what is the type of this? If you just look at, when you write like this, training within the square bracket city, so it is data type of object. Object is categorical variable. Okay. So let's begin with this. There is another variable area. So its data type is int64. It is numerical. Uh, SNS not this plot. So this plot, it gives us the distribution of the data points. Right? So similarly, we have done this for all the variables that are present in the data set. Okay. So if you just look at, there is another variable animal, right? And it has only two values, accept or not accept. And it is a object. Object is a categorical variable. So next point is the missing value analysis. So these are the values, city, area, rooms, these are the columns. And missing value analysis, there's it gives us how many missing values are present. So if you just look at, there are no missing values present, so there are no missing values. That is written here. Next is the outlier analysis. Yes, this is the box plot. So if you just look at this, I have shown it in the presentation. Above this dotted lines, whatever you are seeing, you can see I am moving the cursor. So those points are the outliers. Okay. So outliers are calculated for all the variables. Okay. So if you look at this, yes. So these are the outliers that you can see. Right. So column names, these are the numerical values, and categorical variables, these are the categorical variables. Okay. So let's begin with next one. how many missing values are present, that needs to be taken care. So area is the variable in which there are 672 missing values or 672 outliers. So if you convert that to percentage, it comes out to around 6.28. So what is the percentage of missing values, or what is the maximum percentage of outliers that are accepted? So it is 30%. If it is less than 30%, then only we are going to impute. If it is greater than 30%, then we are going to skip that variable because it gives erratic answers. Okay. So we are going to impute area, right? So for that, what we have done, location 70, right? Log I, draining of area dot log 70. So the variable area which is at location 70, its value is 220. Okay. Next, what we are doing is that value is initiated with NAM, and then look at this, it is giving NAM, and then finally we are imputing whatever NA values we have. Okay. Impute it with mean, right? And then check out what is the answer that we get. It is 116. Okay. So similarly, you can do it with median and KNN, but because of shortage of time, I'm just giving you the idea, right? So next is the area. Look at this. Okay. Training values. So these are the numerical values. Next is feature selection. Okay. So what is feature selection? Out of these variables, how many variables are significant? So if you just look at this is the heat map. Call it as heat map, wherein it gives us correlation values. So if you just look at this, there are diagonally 1, 1, 1, 1, all the values. So area here it's 1, and here also it's area. Right? Area to area is 1. So any variable with itself gives a value of 1. So what is that map is showing? So 1 represents highly correlated, okay, and highly positively correlated. -1 highly negatively correlated. So whichever variables have the values which are near to 1, then those variables we need to skip. Okay. So fire insurance, if you look at this, where is the fire insurance? Check it out. So that variable needs skip of fire insurance, right? Fire insurance and rent amount. Rent is the final categorical variable, final numerical variable, sorry. So it is having value of 0.99. So this value is highly correlated, right? So this value is dropped off. Look at this. So drop fire insurance. Okay. And next is feature scaling. So there are two types of feature scalings. One is uh, standardization, which we are using. Okay. And look at this. What is standardization? Why we need to scale features? Suppose there are 10 people who have the salary of, out of 10, there are 4 people or 2 people who have the salary of around say 50,000, and then there are few more who have salary of around 20,000. Okay. So if you just want to make it uniform, what we do is we scale everything with this within the scale of 0 to 1. So for that reason, standardization is done. Another method is normalization. So we do that in order to make it uniform. Okay. And finally, this is sampling. Okay. 80%, 0.8 corresponds to 80%. So training is 80% and testing is 20%. And next comes is the models. So first one is the linear regression. Okay. So this is the code for linear regression, and these are the results that we obtain. Right. Then how to evaluate the correctness or model evaluation. It is nothing but there has to be a metric. So it is nothing but MAPE, mean absolute percentage error. It should be ideally zero, but that system is not existing anywhere. Right? So this MAPE should be as low as possible, mean absolute percentage error. Right? So for this linear regression, it is 1.7. Next, we are using another algorithm called as decision tree, which gives us, look at this, MAP of 16.09. And next, there is another random forest, which gives us around, look at this, 0.77. Okay, so and out of all the features, which is the feature that is of most importance is this H4. Okay, so this is about the, and these are the R squared values, RMSE, root mean square error. RMSE stands for root mean square error. Right? So within the time I have tried to cover up. So any queries, please be open in the chat box.